Welcome to this video in which I will show you how to prepare external works designs for new developments in AutoCAD. In the description of this video, I will leave a free downloadable cheat sheet in which will have key information, which you can download and put on your desktop and refer back to it whenever you are creating external levels drawings. Before you can make a meaningful start on an external works design, there are some information in the form of Xrefs you will need. These are a site layout, a topographical survey, and proposed road contours. So here we are in this example CAD file. You can see I have overlaid the site layout, topographical survey, and the proposed road contours. The first thing I'm going to do is populate the drawing with blank spot levels where I know I will need them and a blank floor level for each plot. Firstly, you want to put a spot level at key points along the back of footway. The key points where you will need a spot level at the back of footway are where parking bays meet the back of footway in each corner. And you will also want a spot level where any paths leading up to plots join the back of footway. You can then continue adding the next blank spot levels. The positions of these will be one at each entrance to each plot. In most cases, this is just a front and rear door. One in each corner of parking spaces. One at all four corners of each plot and garage. One in each of the rear corners of each plot garden. We may need to add a few more when we are getting deeper into the design, but this will give us a good base to start with. Let's also go ahead and put a blank floor level onto each plot and garage. Now it's time to put accurate levels on the currently blank back of footway levels. This should be a nice easy place to start, as these levels will be fixed by your proposed road contours. Simply input the levels based on your highway contours. You may need to interpolate levels that are between two contours. It's usually okay to round these to the nearest 25 millimeters, unless it's particularly necessary to be more accurate. There are different options of where to go next. However, I prefer to get a good idea of my floor levels at this point. These may change very slightly as we get into the details a bit more. Please find the free cheat sheet in the description for more detail on how to set floor levels. Typically, you want the floor level to be at least 150 millimeters above the back of footway level. It's generally good practice to have adjacent plots coursing with each other. Try to only lift or drop adjacent plots in increments of 75 millimeters relative to the neighboring plots. This avoids potential difficulties with brickwork during construction. Garages should typically be 150 millimeters below the lowest adjacent plot. Now that we have the floor levels set, let's work on the external levels at the front of the plots and the parking spaces. The main entrance to the plot should generally be a level threshold. So set this level to the same level as the finished floor level. We then need to check the gradient of the path to see if it is not steeper than the maximum gradient. Refer to Part M guidance for more detail, but generally try to have a maximum gradient of 1 in 20. If your path is steeper than this, refer to the section of the provided cheat sheet regarding the main entrance hierarchy. Annotate this gradient down the path. The arrow should be pointing down the slope. If you are unsure how to calculate the gradient of the path, take the horizontal length of the path and divide it by the difference in level from the top of the path to the bottom. This will get you a gradient in the format 1 in X. On screen now, I will guide you through my thought process when inputting the levels for the front of this plot and parking bays. As the corner of parking here is very close to the entrance, I will keep this level the same as the entrance level to avoid stepping up to the door. As a starting point, it's good to have external levels around plots to be 150 millimeters below floor level. So here, I will assume that for this corner level for now, and similar to the scenario for the other corner, this level is quite close to the plot, so we will put this parking bay corner at the same level. Now that we have all four corners of the parking bay leveled, we can see that the levels fall towards the front of the parking. So in this scenario, I will show a channel drain across this low side to drain these parking bays. Finally, I will calculate the slope falling toward the channel drain, or gully, and annotate this accordingly. Remember to refer to the free cheat sheet if you need to remember how to calculate the gradient, or to find general rules of thumb for maximum and minimum gradients. I'm going to do the same for this neighboring plot now. Notice this corner should be at least 150 millimeters below the floor level. I don't want any crossfall across the pathways between the plots, so I amend the corner of the previous plot to suit this level. Now for simplicity, I will put this corner at the same level as the corner of the plot. Remember, the external level at the front door should be the same as the floor level. Again, to avoid stepping up to the front door, we will have this corner at the same level. For this corner of the plot, as there is nothing going on in the layout here, we can easily bank down 150 mm from the front door to achieve the lower level at the corner of the plot. Just make sure that the 150 mm bank is no steeper than 1 in 3. We will then go ahead and put the drainage and gradient annotation on the parking bays. I would recommend doing all of the previous steps for just one small parcel for now. For this example, I will just do these 2 plots. We will fully complete each parcel before we move on to the next. So, now let's move towards the sides and back of the plots. As per the general rule of thumb, I will put this corner 150 mm below the floor level, as there aren't any constraints here. Alternative entrances should generally be 150 mm below the floor level, so this back door will be set at 50. When working on closely adjacent plots like this, I like to work on the lower plot first. This is because I will set the corners to 150 mm below floor level on the lower plot, and that will dictate the levels on the corners of the adjacent plot, and we can then show the required exposed brickwork. If we did this the other way around, we could end up tanking the lower plot, or requiring double damp proof course. I will explain this in more detail shortly, or you can refer to the cheat sheet. As mentioned before, I don't want a steep crossfall across these paths, so for simplicity, I will keep this corner level the same as the adjacent plot. And of course, the back door external level will be 150 mm below the floor level. It is always worth checking the gradients of the path up to the back door to make sure you don't require any steps. Then, as there are no constraints here, I will put the corner level 150 mm below the floor level. Since we now have all the levels around the plot, let's add the required exposed brickwork. For a visual reference as to when to use exposed brickwork, see the cheat sheet. Essentially, additional courses of exposed brickwork are required where the external level is more than 2 courses of brickwork lower than the floor level. You can see here that I will draw a line which will start where there is no exposure, and it will taper to get thicker to where I need 2 courses of exposed brickwork. I will then annotate the number of additional brickwork courses required. This does not include the first 2 brick courses, as this is usually standard. Remember, a brick course is 75 mm, including 10 mm of mortar. If the external level does not round nicely to a whole number of brick courses, always round up your annotation to the higher number to ensure this is priced for. Now, all that's left to do for these 2 plots is level the gardens. The garden boundaries will typically be constrained by either being bounded by another plot's garden or the site boundaries, such as in this example. We are going to want to tie our levels into the existing levels at the boundary. However, you can see here, the existing boundary level in grey is quite significantly higher than our levels at the plot. For this reason, I am going to slope the garden as steep as the developer is willing to go to get as close to the boundary level as possible. I am using 1 in 12 as the maximum garden gradient here. I also want to keep the levels either side of neighbouring garden fences the same level where possible, to prevent requiring additional retaining. You can see that the proposed levels still do not tie into the existing boundary levels. To make up for this level difference, I will show the required retaining wall. I will draw the full extent of the required retaining wall and annotate the height of the wall at the back of each garden, and when there is a turn in the wall, the height of the wall is simply calculated by taking away the lower level from the higher level. And that is these 2 plots complete. Now is a good time to have a once-over of your design and see if there is any value engineering that could improve the cost-effectiveness of the design. For example, reducing retaining by using 1 in 3 slopes, or utilizing a cheaper retaining wall option, such as gravel boards, where suitable. Hopefully this video was helpful, and with the help of the free downloadable cheat sheet in the description, you can be well on your way to designing external levels. If you have any questions, feel free to leave them in the comments.